Hey, what's up everybody? Welcome back to another Layer by Layer. This week we finally got the Raspberry Pi Zero. So here it is. We 3D printed the case and there's a couple edits that we needed to do. So today we're going to go ahead and update those in Fusion 360. So let's take a look now. So here's the case that we made, and the first thing we need to do is actually update the standoffs. The position of them aren't exactly right, but we can update those easily. Another thing is that the portholes for the holes for the ports, they're lining up okay vertically, but we need to line them up horizontally. So what we can do there is just update the height of the standoffs so that they're lined up exactly. Another thing we found is that the SD card isn't. You need more. We need to get rid of this bridge because we can't get to. Although you can get the card in, you can't get it out because it doesn't have a spring. So we need to actually cut away this bridge and open it all the way up so that we can get to it and take it out. Another thing we'll do is make a cover for the case so that we can close it off, and I think that's all we're going to do for this one. So the first thing we'll do is update the standoffs. So here's the sketch for the standoffs, and the cool thing about the sketch here is that since we used it from our template, the way we created this in the original template was that it's actually a mirrored sketch. So if I update this once, it'll update it to the rest of the three standoffs. So another thing is we can measure the distance between the standoffs. So if we take a look at the technical drawings, you can see it's actually illustrated here that the distance between these two standoffs here are actually 58. So if we go into CAD and we hit I on the keyboard for inspect, we can measure the distances between this. So if I click on that one, and then I click on this one, it'll tell me the distance, which is 60. So it's supposed to be 58. So if we do a little bit of math, it's actually 2 millimeters, and if we divide that by 2, it needs to be adjusted by 1 millimeter on each side. So what we can do here is we have the measurement, the sketch dimension already laid out, so it's at 2.5. So that just needs to be 3.5. So if I update that, you can see when I hit enter, it updates all 4 of the standoffs, and then I'll update it on this axis, 3.5, and then that's pretty much it there. So that's looking really nice. Another thing I want to do is I actually want to change the mounting type. So we were going to use mounting holes so that we can add machine screws. Instead, I actually want to make pegs. So instead of having 2.5, I want to make it 2.4, so it's a little bit smaller and it fits in through the hole there. Into the mounting hole of the actual PCB. So that's what we're going to do. So that's pretty much it there. Our standoffs are now fixed, and if we hit stop sketch, our case will actually be updated. So if we take a look at the case, it is now updated. So the next thing we want to do is change the height of the standoffs. So to do that, we can actually come here to the parametric timeline and just modify that feature. So all I have to do is look for it, double click it, and then change it. Extrude number 10, so double click on it. You can see here it says 4.4 millimeters plus 1.4, which is the height of our bottom. So I'm just going to change that to 3 and hit OK. And now we have our updated height. So now when we print it, the ports will be lined up vertically. Okay, the next thing we're going to do is update the mounting holes so that they're now they're pegs. So if we take a look at the extrude, it didn't include the hole, so we actually didn't create any voids. We just extruded and didn't include that. So we'll actually have to create a new extrusion. So I'll just bring up the case sketch and then hit E on my keyboard and then just click on the little guys here. The little holes that are going to be pegs. Okay, now that they're selected, we can just pull upwards on the manipulator, and you'll see that it's trying to create a cut by default. So what we need to do is change the operation from cut to join, and then we need to make them a little bit taller. So we'll just bring it up here to about 6.5. That looks good. Now we can hit OK to create that. And now we have our pegs for our standoffs. So that's looking pretty good. The next thing we'll do is we need to create a cutout for this. So we can just modify our SD card sketch. So we'll just double click on that to go into edit mode. And then we already have a sketch dimension for the height, so we can just add a number like 8 to double it, and that looks pretty good. So I'll hit OK, and then hopefully so now the whole bridge is removed here because we already extruded it, and it just sort of follows through that. Okay, so that looks really good. The next thing we can do is we actually need to increase the height of the we need to increase the height of the overall case so that we have enough room. The distance between this and this part here isn't really enough because we're going to create a cover for it, and the cover is going to smash into this part. So we just need to increase it by 1.5 millimeters, and probably just 1 millimeter. But before we do that, let's go ahead and just create the cover. So let's do that now. So instead of like modifying the existing sketch here, I already have a lot of stuff here and I don't want to mess with it too much. So I'm just going to create a new one and just sort of reference it a little bit. So to do that, we'll just hide this sketch and we'll click on the rectangle sketch, and then we'll click on this axis, and then we'll start from this corner here. Okay, so I'm going to create the cover and just use the same dimensions of the pie, which is 65, sorry, by 30, and then just tab and then hit enter. And now I'll create our offsets to accommodate for the actual case. So that's the size of our PCB. We have the distance of 1.5, so they have a little bit of leeway inside the actual enclosure. So we'll make that offset, and then we need to make another offset right here, which is 1.4, which is the thickness of the actual enclosure itself. So hit OK. So the next thing I want to do is I want to create some reference points for creating an intersection for our GPIO header. So we're going to create a hole for the GPIO header so that we can access it. So what I'll do is I'll just make a circle to reference our mounting hole. So I can just click here. Let's just make it 2.5 or 2.4 really. Hit enter, and then I'll use the sketch dimension to align it so that it's 3.5 millimeters away from the PCB on all sides here, on the X and the Y. 5. Okay, so now that it's this first reference point is set up properly on the corners, now I'm going to make a construction line so that we can make a mirror of that. So to find the center again, all we have to do is roll over to an edge until we get that triangle, and then just click to make our line. So now I'll select the line and just click on this button here to make it a construction line. So that's a reference point. So now to make the mirror, I'll select the circle, and I can come up here to sketch and then hit mirror, and that object is selected. The next thing is I'll click on mirror line and then click on our construction line that we made that's in the center, and then we'll see a preview of the mirror and then hit OK, and now we have our reference point for making a hole for the GPIO. So the next thing I'll do is I'll make another construction line and connect the center of these two mounting holes together. So I'll just click it like that, and then I'll select the line and turn it into a construction line. Okay, so now we actually have an intersecting point to reference our cutout for the GPIO header. So I'll click on the rectangle, and then you actually have 3 features types here in the rectangle sketch palette. So I'll actually click on sketch or center rectangle, and then I'll just start and click on the intersecting point of these two construction lines. So I'll click on that, and now I can start drawing out. So the measurements, I already calculated them out. They're 51 by 5.6. So that's the size for the cut for our GPIO header. So I'll hit enter, and then that's set in there. I'll just update these a little bit here, just move these out of the way so I can reach them later. And that's pretty much all we need for our case. One thing I'll do is to accommodate for some of the tolerances, especially for PLA, I'm actually going to create another offset that's going to be 0.1. So I'll click on the offset button, and since this part here is the edge of the enclosure, this one here, I'll bring it inward here by 0.1. So just put 0.1 like that and hit enter. And now we have our sketches for creating our nifty case cover for the case. So now I can use this sketch to make an extrude. So I'll hit E on the keyboard and select all the features in there, including the cutouts. Actually, no, I don't want to include this cutout, obviously, because that's the cutout for the GPIO. Now we're extruding. I'm going to make it the same thickness as the bottom and the thickness of the enclosure, so that's 1.4. So I'll hit enter. So it's going to create a new body. We can rename that body to cover. Let's keep it organized. And then the next thing we need to do is create the lip for snapping into the case. So we'll bring back our sketch, sketch number 5 here. We'll rename it in a second. And then I'll just extrude this piece here. So I'll hit E on my keyboard and just click on that. And then I want it to be 1.4 plus, let's say plus 3 millimeters. Or 2. Yeah, 2 looks good. And then I'll change the operation from cut to join. And then I'll hit OK. And now we have our case, our cover for our case. So now I can hide the sketch that created it. Let's speed it up a bit. And the next thing I need to do is create some fillets. So I'm going to create those really quick. I'm just going to hit F on the keyboard and click on the corners here. And I already remember that the fillet is at a radius of 3 millimeters. So once the 4 corners are selected, I'll just hit 3 on my keyboard and hit enter. And there's that. The next thing I need to do is create a fillet for the lip, so on the outside. So that's actually going to be, I can actually reference it real quick. So I can bring back the case, hit I on my keyboard, and then just click on this inner portion of the thickness of the enclosure, which is 1.6. So that's the radius that I'll use for the lip. So 1.6. Hit F on my keyboard again, and then just select those four edges. And when they're all selected, I'll just set 1.6 and hit OK. And then that's pretty much all I need to do there. So now we have our cover. So what we'll do next is we'll bring back the cover, or the case, and then we'll move the cover so that it's on top so that we can reference to see if there's anything intersecting. So I'll go ahead and hit the move, and I will need to hide the case for a second, and I'm actually going to change. You see how the manipulator's set over here, like way offset? That's not what we want, so we can use the set pivot function feature to like go in the center. So we can roll over different areas of the part that we want to move, and just click on that, and then hit the checkbox to set the pivot. So now we can rotate it this ways by 90 degrees, or 180, like that. And then we'll move it up a bit. And what's cool is that we can reveal and bring back the case while we're moving it, so we can see how high we need to go, really. So now I'll move it up, and then you can see that we're actually we're intersecting a little bit with that portion of the cutout. So we need to go up just a teeny bit. So like right there. So 12.5 is how high we're going to go. And you can see that now we need to make a quick edit to the thickness of this guy here, of the actual case itself. So it needs to go, I think, 1 millimeter. So let's use the measurement tool again. I'll click on that edge and that edge. You see the distance between them is actually 0.9. So it's not a millimeter, it's actually 0.9 millimeters. So that's okay. Well, so 0.9 was it. We'll go to our timeline here and find out exactly where we need to make that. So I think it's this part here. So you can just double click on that. So it's going to be 13.9, 9 like that. Hit enter. And now we have a flush case. So now they're lined up perfectly. Okay, so the next thing I want to do is actually create a cut right here. we need to create a cut right here so we can actually access the, so we can put our thumb in there and take out the SD card if we ever need to. So when I updated, you can see here the bridge came back in the case because I updated the height of it. So now I can just go back into the SD card sketch and then just increase the height a little bit. So it was 8. I'm going to go ahead and change it to 9. Hit enter. And then hit stop sketch. And now it looks like we have gotten rid of our bridge. So that's good. Alright, so I'm going to make another sketch now. And I'm actually going to sketch on top of this edge here so I can quickly reference an area. Because I just need to make a cut here for the case. So that's what we'll do. I'll click on the rectangle and then click on this area here and it projects the sketch for me. So I'll go ahead and click here and then just start drawing out. How far we want to go, we can kind of play around with it a bit. So it's going to be 15.5 and I'll tab, then I'll put like 6. So hit OK. Now I've created our little cut for the case. So I'll hit stop sketch and then I'll hide the case and bring back the cover. And now I can start creating a cut using the extrude. So I'll hit E on the keyboard, select the 2 features of it, and then instead of just pulling it up, I can pull it up, but I'll do it quicker. I'll just change the extent from distance to 2, which is making it dynamic. So now I can select this surface here of the case, and it's kind of dynamic. So if I ever update this or move it around, it'll always know to extend that far with the extrude. So that looks good. Now if I bring back the case, you can get a better idea of how the opening is going to work. So now we have a little bit of extra opening so that we can get to that SD card. Now just for some cosmetic stuff, I'm going to add a fillet here. And then I'll also add a fillet on this part here on the edge so it's not so sharp. I'll put 1.4 because that's the total thickness of the enclosure. And that's looking really, really nice. So that's about all the edits we need to do for the enclosure. We now have our 2 pieces. We created a tiny bit of clearance. That's a 1.2 millimeter or 0.1 millimeter clearance. So that's going to work really well, especially with PLA and probably other filaments as well. So I'm going to go ahead and 3D print that, and when we come back, we'll take a look at how it worked. Alright guys, so here it is 3D printed. Everything's working out really good. The pie can fit right inside, and the standoffs and the pegs are all lined up perfectly. We double checked to make sure that all the cables and adapters fit inside of the portholes, which they do, which is really nice. The SD card opening worked out really well, so I can get my fingernail in there and pull out the SD card if I need to, and then pop it back in. Another thing is the GPIO header. We were able to get a Pi TFT, an Adafruit Pi TFT hat, like the display, to fit right on top, so you can access all the GPIO header with this opening, which is really nice. All the tolerances work really well. It 3D printed in about 30 minutes, so that's really nice. And I'm really proud of this one, so definitely check it out. I'm going to go ahead and upload this to Thingiverse because it all checks out. It's going to 3D print on just about any 3D printer because it's like 70 millimeters or so by like 35 or something like that. But definitely check it out. Of course, the Fusion 360 design is available, so you guys can download it. If you have some other package, you can download a SAT file, or there's so many other different formats that you can download in the archive. So go ahead and check that out. But if you get it for Fusion 360, you'll get the full parametric timeline, so you'll have all of the editing capabilities, which is really nice. So if you haven't already, guys, definitely try to get yourself a Pi Zero. I know they're out of stock and they're really hard to get, but we're gonna try to get some more in the Adafruit shop in the next week or two. No promises, but definitely keep your eye out on it. So there you have it, the Raspberry Pi enclosure. This is the smallest and cutest thing. I'm gonna be doing so many projects for it. I'm definitely thinking about making a Raspberry Pi Game Boy using the Pi Zero to make a little micro, for example. So be on the lookout for that one. I hope you guys learned a lot. I know I did by making these tutorials. If you haven't already, check out part 1, which is going to be linked over here. And there you have it. So let me know if you have any questions, folks. If you have any questions, drop them in the comments, and I'll go ahead and answer those on our live show that's on every Thursday. But until then, thank you guys for watching, and remember to keep on catting.